This is practice A for section 6.5. On this worksheet, we're going to look at these two theorems, the triangle proportionality theorem and the converse of the triangle proportionality theorem. The triangle proportionality theorem is theorem 6.4, and it tells you when you have a triangle inside of another triangle, these two triangles are going to be similar. And if you want to make things quicker for yourself, this to this equals this to this. So remember in the lesson we did it like this. A to B equals C to D. So this would be our A, the thing that we're looking for. This could be our B, or this could be our B. It's up to you. There's a couple different ways you could do this. We'll call this the B right now. This would be the C, and this would be the D. We're comparing an entire side with an entire side. We're also comparing something that is not a side with its corresponding part that is not a side. That's why this proportion works. Now, you can cross multiply to solve this proportion, or you can realize that 6 times 2 is 12, so 5 times 2 is 10. You would do this one the same way. Determine whether the statement is true or false and explain your reasoning. So we have another very similar diagram. You have a triangle inside of a triangle, and they're telling you that this side is parallel to that side. That means that this to this is equal to this to this. And that's exactly what this says. A to B compared with B to D is the same thing as A to C compared with C to E. This is true. Number 4, A to C. That's the entire right side of the small triangle. We're going to compare that with C to E. And this looks normal so far. This is not an entire side of a triangle. It's a little piece. Is that the same thing as this entire side compared with this entire side? These are not the same because this is not an entire side of a triangle, so you can't compare it with an entire side of a triangle. If that doesn't make sense, then what you could do is draw the two triangles separately. There's segment AC. There's segment BC. So you have an AC and a BC. Look at this other one now. This is the big triangle. Here's segment DE. But where is segment CE on this diagram? It's not on here. Okay, so that's how you know something's up there. You can't compare part of a side with an entire side. Same thing happens in number 5. E to C is part of an entire side. Compare that with segment CA. That's fine. You can do that. But you better compare this segment EC with segment BD, and you don't do that. Compare it with segment ED. That's an entire side. So that doesn't work either. This is also false. If you wanted to make this true, you could keep this. EC to CA, that's fine. Make that equal to segment DB compared with segment DA. That would make a true statement. Here's number 6. Segment DB, that's part of an entire side. Compare that with segment BA, that's an entire side. Over here we got segment EC, that's part of a side. Compare with segment CA. This is true.